This is the rest of the notes for section 9.1a, where we're graphing some of the simpler parabolas represented by these quadratic functions. And remember, when it says f of x, that's function notation for y. It's what comes out after you put x's in. And so we are graphing, and we are plotting points and making a table. And this is my y equals, and my y is -3 times what I get when I square x's and add 1. And so we first put in a 0. When I put in a 0, I get -3 times 0 squared, which is 0, plus 1 is 1. And then I'm going to be nice to myself, because whatever I plot, I pick for x, I have to plot on my graph. So don't let x be 100 or 5 or even anything negative for that matter. Even though the domain is, for all of these, all real numbers, or you could say any number or all numbers, we're going to be very selective about what we put in, because what we put in we have to graph. So because I don't have to do any halves or thirds or anything like that, 1 would be a really reasonable choice. So my y would be -3 times 1 squared plus 1. Again, order of operations is really important here. Exponents get done first. 1 squared is 1. -3 times that is -3. Plus 1 is a -2. So -2 is in my range. 1 is in my domain. I am going to put a 2 in next. When I put in a 2, I get -3 times 2 squared plus 1. Again, 2 squared is 4. -3 times 4 is -12. -12 up 1 is at -11. That's enough. All I need is 3 points as long as one of them is the vertex. And when there's no b term, we said that vertex is at 0. We'll discuss why in a later section. So we've got 0, 1, and then I've got 1, -2, and I've got 2, -11, way down here. Notice how skinny it's getting, and it's because it's getting really stretched out. It's getting stretched down because of the negative, and 3 times as far as what that parent function was. So this is the right-hand lobe of my parabola, and it goes forever, so we put arrows. And to get the left-hand lobe, I just use some symmetry here. So I just go like that, and that's my parabola. It's a little curvy, but good enough. And again, remember the vocabulary. We call this the vertex. We call this line splitting it in half the axis of symmetry. And because our vertex today is going to be when x is equal to 0, today our axis of symmetry is always just this y-axis, or the line x equals 0. All right, so let's go down here. And we're going to have a discussion about what effect these numbers are having on the graph. Remember, we've got ax squared plus bx plus c. And we're going to discuss what these coefficients, the a, the b, and the c, have on the effect of the graph. Keep in mind that parent function, that's kind of considered like average Joe, where when you put in a 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, and it's just kind of a nice average with parabola that opens up. We're going to now start talking about, well, what happens when we start changing these numbers around, like maybe we put a -5 out front and a +10 on the back. What effect is that going to have on the graph? Well, it's kind of like when we did with lines when you were in linear algebra and you would have to graph -1/2x plus 7. These numbers affect the graph of the line. You should remember that when the slope is negative, it means the line's going downhill. And the bigger the number there, the steeper the line. So we're going to first start looking at what the first coefficient, which is the a, has on the graph, and what effect the last coefficient, or the c, has on the graph. Keep in mind, we're kind of leaving b out of the mix here in section 9.1. b will come into play in section 9.2. So if I were to graph these on my graphing calculator, which I will in a minute, first thing I'm going to do is go get that parent function down though. So remember, when there's just y equals x squared, we call that the parent function. And it goes through 0, 0, 1 squared is 1, 2 squared is 4. This is the one that we're going to be comparing the other ones to. So kind of look at its shape. It's of average width. It's opening up. It hits at 0, 0, which is where its vertex is. And what we're going to do here is see what happens when we put a negative in front, see what happens when we put a 5 out front, and see what happens when we put a fraction out front. And we're going to see what effect that has on the graph up here. So first thing I'm going to do is go to my graphing calculator here, which I have logged in behind it. Just go click on it. I think if I can click on that, there we go. So the first one we're going to look at is y equals negative x, negative, this is touchy, x squared. We're going to see what effect that has on the graph. All right, so when I keep in mind, you might want to kind of predict what's going to happen. These are saying the y's are the opposite of x squared. So when we were graphing the parent function, we said 2, 4, negative 2, 4. But this has a negative in front of it. So watch what happens when I hit. I'm going to make sure my window is good. Look at what happens here. It's like it tipped the parent function over. The parent function, I'll go put it back on there, by the way, because I like to compare them all to it. The parent function is just x squared. And we graphed it already in your notes, but just so you can see what's happening, that negative in front seems like it just tipped it over. All right? Well, I'm going to go do all of them at once here since I have the graphing calculator out. The next one in your notes, and we'll go put them on there in a minute, was y equals 5x squared. Well, let's see what happens when we graph this one. And let's discuss why. So I'm going to hit graph here, and you'll see the graph of y equals 5x squared here in red. Well, notice that the graph of x squared and negative x squared, color code them here, green and blue, are of the same width. The blue one's opening down, and look at that red one. It got a lot narrower. Well, let's talk about why it got narrower. It's because the y's are being stretched out 5 times what they were on the parent function. So it's getting 5 times as high. It's kind of like if I grab you by the head and just stretch you to 5 times your height, you're going to get very skinny and very narrow. So let's see what happens when we put that 1/5 in front of there. So back to the next function here. I'm going to go put a 1/5 x squared on my graph and see what that fraction's effect is on the graph. And I'll hit graph. Oh, and it made it very fat. So we've got 4 functions up here on the screen. We've got the green, which was the parent function that we're going to be comparing everything to. When we put a negative in front of it, it didn't change its width, but it tipped it over and gave us the blue one. When we put a 5 in front of it, it made it very narrow and gave us this red one. And when we put a 1/5 in front of it, it made it very fat and gave us the black one. So let's go back here to our notes and see if we can figure that out. So it says right here, let's go put them on there. When we put the negative in front of it, it just really tipped the parent function over, or tipped it on its head. So when a is negative, it seems like it just flips the graph over. And we say that this is really what we say is that the parabola opens down. Down frown. So think negative equals frown equals opening down. All right, what effect did that 5 out front have on it? Well, instead of at 1, 1, I end up with 1 squared is 1 times 5. It shoots way up here. It makes it very narrow. People think common mistake for kids is they think a big number in front of there is going to make it fat. It actually stretches it really high and makes it very skinny, kind of like if you stretched your silly putty out, it's going to make it very thin. And likewise, that 1/5 made it very fat. So let's go summarize that down here. It says, what happens when a is positive and gets larger, like that y equals 5x squared? What we say is the parabola got narrower. Understand why, though, so you don't have to memorize it. It gets narrower because y is how high it gets, and it's getting stretched 5 times its height, which is making it very skinny. And then it says, what happens when a gets smaller than 1, like on that 1/5? x squared. Well, this is kind of like I'm making it get 1/5 its height. It's like if I push down on your head to make you a half of your height, you kind of pop out the sides and you become very fat. And what we say is the parabola gets wider. All right, so can you predict what's going to happen with these? And I'm not going to graph these in your notes, but this is going to cause it to flip over and get very skinny. This is going to cause it to open down and be fatter than the parent function. So overall, what effect does A have on the graph? It makes it open up or down. Up, makes it open up or down, depending on whether it is positive or negative. And it makes it narrower, and again, it's narrower than the parent function, or wider than the parent function, depending on what the number is. It's narrower actually if it's a big number, like 6 or 7 or 8. Anything bigger than 1 will cause it to stretch out higher. And wider basically if it's a fraction or less than 1. All right, I want to get these done here quick, so I'm going to go kind of fast through the last page here. So right here it says order these from widest to narrowest. Keep in mind the negative just makes it flip over. So here's our parent function, okay? This 4 is going to cause it to get stretched 4 times its height, and it's going to be tipped over. This one's going to be very narrow. This one's going to be the fattest one. So 1/4 x squared is the fattest. It's like it's getting squished to 1/4 its height. It's popping out the sides, and it's getting quite wide. X squared is the parent function, which would be in the middle. And the negative 4x squared is going to tip it over but stretch it to 4 times its height, so it's going to get very narrow. There's a couple of those in your notes. I'm going to skip this one for time's sake. And now we're going to see what the effect of tacking on a c here does to the graph. So notice here's my parent function again, 0, 0, 1, 1. 2 squared is 4, negative 2 squared is 4, going like this. We're going to see what effect that adding or subtracting something does to it. I don't have time to go to my calculator because I want to have this done here. I've only got 2.5 minutes. So we're just going to discuss what happens. Remember, your f of x is your y values. So think of the parent function. What I'm going to do is keep that the same, and all the y values are just going to get pushed up 3. So when I put in a 0, I do 0 squared plus 3 is 3. When I put in a 1, instead of getting 1, 1, I'm going to get 1, 4. And so basically what's going to happen with the introduction of that addition on the back is the graph is just going to move up. Notice it's still centered on this y-axis because that's what the b term being 0 does. It keeps it right with that y-axis being the axis of symmetry. Likewise, over here, when I subtract 2, it's going to be like I'm taking this whole thing and just moving it down 2. So when I do that, I'm not affecting the width because I don't have anything going in front here. I'm not tipping it over because there's no negatives. It simply is just going to move it down 2. All right? So you'd be at 0, negative 2, and instead of 1, 1, you'd be here. I'm just going to draw it nicely. Notice all of those are opening up because we've got positive, positive, positive lead. They're all the same thickness because they all have a 1, and a 1. But tacking on that C moved the graph up and down. So it says, what is the effect of C on this graph? The effect is C moves the parabola up, it's positive, or down, if it's negative, its axis of symmetry. So basically it just kind of moves it up or down. It doesn't affect its thickness or anything. So let's wrap this up, the last one on here. It says, a multiple choice question, how does the graph of this one differ from the graph of this one? Well, first of all, let's talk about how they're the same. They both lead with a positive A, think positive smile, they both open up. Plus, they both have a positive 2, which means they both have the same thickness. A affects up or down, positive, negative, and affects thickness and how wide it gets. Those are actually of the same thickness. They are width, they are both opening up, but tacking this plus 3 on moves that 3 up the axis. So we'd say it shifts 3 up. And we are done. Have a good night.